All right, well, now we're going to look at verifying congruence after a translation. And we can verify that on a triangle or an object, or triangle, by using side, side, side. And that's where we're going to end up. But let's look at what we're being given here. It says triangle JKL with vertices of J is negative 2, 2, K is negative 8, 5, and L is negative 4, 6, is a transformation of triangle PQR. So triangle PQR, that is the pre-image. And triangle JKL is the image. So we're transforming from PQR to JKL. Let's see, and triangle PQR has vertices P negative 2, 8 negative 5, and R 4 negative 6. So we're asked to graph the original figure and its image. Then we're asked to identify the transformation, and then we're going to verify that using side, 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 that it is a congruence transformation. So this problem is a little bit lengthy, but we're first going to start. We're going to go, the next slide, we're going to go to GeoGebra, and we're going to graph the pre-image and then the image. All right, we're over here in GeoGebra, and I've got a coordinate plane up, and we are going to graph. First, we're going to graph triangle PQR. And so I'm going to go over here first, and I'm going to hit my little point. I'm going to say I want a point. And then I'm going to input this by the coordinates that I'm given. So I'm going to say P is equal to 2, negative 2. And I'm going to hit enter. All right, and there it puts in point P and labels it for me. And now we're going to say that Q is equal to 8, negative 5. And it should then put Q in there for me. All right, that's cool. Yeah. Then I'm going to say R is equal to the coordinate 4, negative 6. And I'm going to hit enter. All right, well, there's my 3 points. And now I want to make that, I'm going to join those by segment. And so we're going to say segment, and I'm going to click on this point P, and click on point Q, and then click on point Q, and go to R, and then go from R to P. All right, well, there's my triangle PQR. Now let's do our second triangle, which was JKL. I'm going to go back and hit my point key. I'm going to say I want a point. And I'm going to go in here to my input. And I'm going to say J is equal to the coordinate negative 2, 2. Enter. And it puts J in there. And then we're going to say K is equal to negative 8, 5. Close my parentheses, hit enter. There it labels K for me. And L is equal to negative 4, 6. All right, now we got L. And let's get our segment tool. We're going to say segment, so we're going to go J to K, from K to L, and from L to J. All right. Now, we're going to manually calculate in a few moments the side, 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 but look what it did here. This says that segment F, which is PQ, is equal to 6.71. And if I go down here, it says JK is equal to 6.71. And segment QR, if you follow my cursor, is equal to 4.12. And KL is equal to 4.12. So I got two sides that are of both of these triangles that are equal. And let's look at the third side. RP is equal to 4.47. and LJ is equal to 4.47. And so I couldn't really automatically know that I've got these congruent, but we'll also, because we may need a little practice on the distance formula, do them manually. Hope that's not too laborious. Now we're going to now go and look and see if we can determine what kind of transformation this is. Okay, well, I've done a screenshot of the two triangles that we created in GeoGebra. GeoGebra, again, is a free app. I'd encourage you to get it, particularly on a computer, because it can make this job of all this graphing a whole lot easier. And it even draws straight lines for you, which is just tremendous as far as I'm concerned. Okay, well, now we got to try to figure out, okay, what kind of congruence is this? So if I look at this, and this is my pre-image, that's my original figure, which means that this is my image. All right, so where does it look like things are going to? Well, one thing I can see is I got this long side right here and coming this way, and I've got this long side right there. And so it looks like to me that P is coming over here where J is, and that Q is coming all the way over here where K is, which means that R is rotating, I should give you a clue, right there. And so I believe that we've got this transformation is a rotation. Everything seems to be rotating around an axis or a center of rotation. And I bet my center of rotation, quite frankly, is right there at the origin. Okay. Now, we saw in GeoGebra that we could verify congruence side, but I want us to also get a little bit of practice on the distance formula. And so this, if I've got this rotation right, then let's see. PQ should equal JK, okay? And to a different color. QR should be equal to KL, QR, KL. Okay, that's looking good so far. And then that would mean that RP or PR should be equal to LJ, JL. All right, we're going to see if that's true. All right, so here I've set up the segments along with their coordinates. PQ and JK, those should be equal to each other. QR and KL should be equal to each other, and RP or PR should be equal to JL. So our distance formula is the square root of x2 minus x1 plus y2 minus y1. We're going to consider all these coordinates on the right to be our two coordinates, and the ones on the left are going to be the ones. So let's get the distance then for PQ. So we should have the square root of x2, which is going to be 8, minus x1, which is 2, x2, x1 squared, plus negative 5 minus negative 2. It's going to make that a positive squared, and the square root of that. So let's see, we've got then the square root of 8 minus 2 is 6 squared, plus negative 5 plus 2, those two negatives make that a plus, negative 3 squared. And let's see, we know what gives us 6 squared is 36, negative 3 squared is 9. And so we got the square root of 45. We'll leave it in that form for the time being. Now that should be equal to what JK is. So let's go see if that's true. So I got the square root of x1, that's negative 8, minus 2 squared, plus y2 is 5, y1 is 2 squared. So that should give us, let's see, negative 8 minus 2, that's plus 2, so that should be negative 6 squared, plus 5 minus 2 is 3 squared. And that gives us negative 6 squared is 36, and 3 squared is 9. And that is equal to the square root of 45. Shazam. Okay, those two sides are congruent. Let's go for side 2. QR and KL. We'll proceed the same way. Maybe I'll put this in a different color so we'll see. Let's say we start off with the square root of x2, which is 4, minus 8, x1 squared, plus square root of, plus, let's see, negative 6 minus negative 5 squared, square root of that. Okay, so then 4 minus 8 is negative 4 squared, plus negative 6 minus 5, that makes that a plus. Negative 6 plus 5 is negative 1 squared. And negative 4 squared is 16, and negative 1 squared is 1. So we're looking at the square root of 17. Hopefully KL is going to be the square root of 17. So let's begin. We got the square root of x2 is negative 4, minus negative 8. That's all squared, plus, let's see, y2, we got 6 minus 5 squared. Let's see, negative 4, negative 8, that's plus, so that's going to be 4 squared. 6 minus 5 is 1 squared. And so we got the square, 4 squared is 16, 1 squared is 1, and shazam, square root of 17. So we got two sides of each of our triangle, the pre-image and the image, verified that they are the same length, side, side, side. We're verifying this side, side, side. And let's go to the last two line segments, PR and L and JL. And we're going to continue with it the same way. So we got the square root of x2 is 4, x1 is 2, 4 minus 2 squared, plus negative 6 minus negative 2 squared. And let's see, 4 minus 2 is 2 squared, plus negative 6 plus 2, those two negatives make that a plus, negative 4 squared. And let's see, negative 2 squared is 4, and negative 4 squared is 16, and we're looking at the square root of 20 for segment PR. We could reduce that a little bit, but we're not going to worry about it. All right, let's go JL. Hopefully we're going to get square root of 20, and we will have finished all this mess. So we got the square root of x2 is negative 4, minus x1, which is negative 2, that's all squared, plus, and I really should have a second parentheses right there, just being a little bit lazy. Y2 is 6, minus y1 is 2, and so then we've got negative 4 minus 2, that's plus 2, so that's negative 2 squared, plus 6 minus 4 is 4, 6 minus 2 is 4, 4 squared, and negative 2 squared is 4, and 4 squared is 16, and 4 plus 16 is 20, and so we're looking at the square root of 20. And all three of our line segments of our transformation give us the same, or the same length, have the same distance, and we have verified congruence of this rotational transformation using side, side, side. After we have graphed it on the coordinate plane, it just cannot get much better than that.